Hi there, Rachel Sherman here, and in this video we're going to learn about directed graphs and then apply it to an example. Directed graphs can be used anytime your domain and codomain values are equivalent to each other. So in other words, if you were to take a finite set and you're crossing it with itself, then this would be a good application of the directed graph. On the other hand, if you were looking at infinite sets, whether it's countable or uncountable, it would not be a good use for a directed graph. A directed graph is basically an arrow diagram where everything is pointing only to the values in your domain slash codomain because they're the same. So very similar, but an arrow diagram more specifically separates your domain and codomain values. So let's take a look at an example here. You will draw an arrow from one value to the next in the relation if and only if that ordered pair is a member of the relation. So let's take into consideration the set 3, 4, 5, 6, 7, 8. And we're defining this relation where x relates to y if and only if 2 divides their difference. 2 dividing a difference is a really fancy way of saying that the difference is even. So this will definitely help you as we move forward with the example. This is a case, if you watched the last video, where I would not actually recommend writing out all ordered pairs that you can check here. You'll see that if you have 6 elements in your domain, that's going to leave you with 6 times 6 is 36 ordered pairs. So instead of spending time writing that out, just start by kind of sketching yourself out how you want this picture to go for your directed graph. So those 6 values, I'm going to create 6 points. Try and space them out to the best of your abilities. And just label them 3, 4, 5, 6, 7, and 8. Now, what are some rules that will be helpful for you? Well, if we take a look at this, and you may recall we got a little sneak preview of this when we talked about cardinality, but just think about the property of the integers for a second. If you were to check each one of these numbers with itself, will a value be related to itself? For example, well, x minus x is going to be equal to 0. Does 2 divide 0? The answer to that will always be yes. So you can very quickly see how just by checking, this is what we would call the reflexive property, are things related to themselves, you know that every single one of these is going to be related to itself. So you can draw your arrows to point back at each of these. And that's just one way to help save you a little bit of time. If you identify quickly that something is not reflexive, then you would just check them on a case-by-case basis. Now, let's start working through these. What property, when you subtract, would make these even? So again, these are things you're going to find helpful, so you don't have to sit here and go, okay, well, 3 minus 4, well, that's negative 1. Does 2 divide negative 1? Okay, no, it doesn't, so we keep going. 3 minus 5, that's negative 2. Oh, 2 does divide that, right? So hopefully you'll catch on pretty quickly that anytime x and y are odd, their difference is going to be even. So you'll notice 3 relates to 5, 3 relates to 7, but it will never relate to 4, 6, or 8 because those differences are always not divisible by 2. Now move on to the next one here. Does 4 relate to 5? No, the difference is negative 1, but it does relate to 6 and it relates to 8. And then we can keep going. So of course 5 is going to relate to 7. Oh, but it's also going to relate back to 3. So what you should be noticing now is these are symmetric relations. If 3 relates to 5, 5 has to relate to 3 because the difference is that of negative 2 or positive 2, both of which are divisible by 2. So this should help you in filling out your chart pretty quickly. We can kind of fill in the rest of it here. And should only take a couple of minutes. Sorry for the slight mess that's going on. So a little bit hard to view, but basically this is something which is also symmetric. In the next video, we're going to explore a little bit more about what it means to be reflexive and symmetric and also transitive, which you may recall from the cardinality video. Thanks for watching.